thermal fluid sciences experts. This is ProReadyEngineer.
Hello, this is Bassam Abdelnabi from ProReadyEngineer. I'm excited to share a new video series featuring industry cases. If you like what you see, please consider liking and subscribing. Take care and talk to you soon.
You know, in the world of aerospace engineering, a single bottleneck can end up costing millions and bring innovation to a screeching halt. So today, we're going to break down a really high-stakes engineering challenge and the honestly elegant solution that completely changed the game. Let's get right into it. It really all boils down to this one question. See, in aerospace, testing isn't just important, it's everything. You have to have perfect data because the cost of getting it wrong is just astronomical. But what happens when the very process you use to get that data is broken? Well, a major player in the aerospace industry was struggling with exactly that. Their combustion test campaigns, which are absolutely critical for developing new engine tech, were just hitting a brick wall. And even with some of the best engineers on the planet, their process was fundamentally broken. So let's paint a picture of what life was like before the big fix. A typical test day was this grueling 6 to 8 hour session just to collect about 40 data points. It was slow, it was painstaking, and it was deeply, deeply inefficient. And the consequences of that process? Oof. It took another full day just for post-processing, trying to line everything up. But worse than that, a staggering 15% of all the data they gathered had to be completely thrown out and retested. This wasn't just a little inefficient, it was a massive drain on time, on money, and on team morale. So what was the real problem here? You can pretty much sum it up in 3 words: chasing the set point. Instead of spending their time collecting good, valuable data, the engineers were constantly fighting their own system, just trying to wrestle it into a stable condition. Let me walk you through just how frustrating this was. Operators would have to punch in settings by hand. Then they'd spend the rest of the time just tweaking and nudging the controls, fighting this constant system drift. On top of that, they had to manually coordinate 3 separate computers for controls, data acquisition, and dynamics. It was a perfect storm for operator fatigue and, you guessed it, human error. They were basically just crossing their fingers, hoping they captured data at the right moment. The whole issue really came down to these 4 main culprits. You had manual valve control, which meant an engineer had to be watching it like a hawk. You had fuel air drift, so the burner temperature was all over the place. The control logic itself was way too rigid, it couldn't adapt. And finally, trying to manually sync 3 different PCs, it just created constant delays and errors. The system was practically designed to fail. But then came the solution, and it was a game changer. Instead of fighting the system, they taught it to conduct itself. They built this smart, integrated system that works less like a clunky machine and more like, an automated conductor leading a symphony. Here's how they did it. They attacked the problem with 5 key fixes. First, they upgraded the hardware to a much better valve to stabilize the airflow. Simple enough. Second, they automated those critical valves using what are called PID loops. Think of them as smart feedback controllers that do the tweaking for you. Third, they built a dynamic system where a simple spreadsheet could automatically feed the system new set points. Fourth, and this is the big one, they developed logic that could identify, in real time, the exact moment the data quality was perfect. And finally, they synced all 3 computers with a single unified trigger. The result is a system that's both patient and incredibly intelligent. It automatically brings the test reg up to the target condition. It watches all the critical parameters. It waits for that perfect moment of stability. And then, and only then, it strikes, capturing absolutely flawless data every single time. And right here, this is where you can see the magic happen on the screen. Before, you had these 3 different data streams, controls, DAC, and dynamics, all just kind of wandering out of sync. It forced the engineers to just guess when to hit record. But now, watch this. The system reads the next test point right from a spreadsheet, that steady-state indicator light flips from red to a bright green, and bam! A single trigger fires, and all 3 of those waveforms instantly just snap into perfect alignment. That, my friends, is automated precision. So that green light moment has a name. It's called steady state, and this is the absolute core of the solution. It's that instant when the system itself certifies that every critical parameter is exactly where it needs to be. No more guesswork. The machine knows with mathematical certainty that this is the perfect time to grab the data. So what did this whole symphony of systems actually accomplish? Well, the results weren't just good, they were absolutely transformative. And honestly, the numbers really do speak for themselves. First up, throughput. They went from collecting 40 data points a day to nearly 56. That's a 40% jump in the amount of valid, useful data they could get in the exact same amount of time. Incredible. Next, let's talk about efficiency. The old tests needed 2 engineers, constantly monitoring everything. With the automated system, it only needs 1. That is a 50% reduction in staffing, which frees up those brilliant engineers to go solve other big problems. And now, for the money shots. For just 1 test cell, this new system is projected to save an inflation-adjusted $2.4 million over 10 years. I mean, that is just a staggering return on investment. And remember, that's just for 1 test cell. When they scale this solution across all 5 of the company's similar facilities, the potential savings just skyrocket to over $10 million. This is the real power of finding and fixing a core bottleneck. You know, the best part is this wasn't some decade-long pie-in-the-sky project. The total investment was around $275,000. With annual savings hitting $210,000, the whole system paid for itself in under 2 years. It's just a clear, undeniable financial win. So what's the big takeaway here? This case study is way more than just a cool story about one company's success. It's a really powerful lesson about a smarter way to approach these kinds of complex problems. The key lesson is crystal clear. When you bring together automation, adaptive control, and system synchronization, you can fundamentally transform not just your efficiency, but the actual quality of the work itself. Look, at the end of the day, the money they saved is just a symptom of the real victory here. The real win is faster, more reliable innovation. When you can trust your data 100% and get it 40% faster, you can develop, test, and deploy next-generation technology at a speed that your competitors just can't keep up with. And that kind of leaves us with one last thought to chew on. This team found a huge bottleneck that was hiding in plain sight. It really makes you wonder, what's the equivalent of chasing the set point in your world or in your industry? What's that one hidden inefficiency that if you could just solve it, might unlock this kind of incredible value?